All right, in this video, we're going to be looking at the pink section of your Rainbow Review. Starting with the first one here, we want to change each of these from radical form to using fractional exponents. And so for the first one, everything is under the square of root. So it's really important to use parentheses here. So we would say it's AC to the 1/2 power. Now remember, like for letter B here, when we write a number, when we write an exponent that's going to be a fraction, the numerator is going to represent the power, the denominator represents the root. So this would be the same. So 9 squared, or the cube root of 9 squared, would be the same as 9 to the 2/3 power. In letter C, we have the 4th root of x cubed. Well, that would be x to the 3/4 power. And lastly, letter D would be negative 432 to the 1/3 power. All right, let's look at number 2. So number 2, it says find the specified roots of each number. So the real 4th roots. Now the idea here is that it says it's the real roots. Okay, all of these are real numbers. We're not going to have to use imaginary numbers for any of these. So if that's the case, we can just solve these. So if I'm trying to figure out what's the 4th root of 16, or if I had x to the 4th power equals 16, I want to figure out all the real roots that we could get here. So we would take the 4th root of each side, and so we would get, anytime we take an even root, to solve this, there's going to be 2 possible answers. Okay, so there's going to be a plus and a negative, positive and a negative. And the 4th root of 16 is 2, so your answer here would be plus or minus 2. Letter B, we're trying to find all the real square roots of 36. So if I take the square root of both sides, again, I would end up with a plus or minus. So we're going to have x equals plus or minus, square root of 36 is 6. And the 5th roots of negative 1024, again, I would take the 5th root of both sides. When we take an odd root of a number, we're not going to have 2 solutions, we're just going to have 1. And so your answer for this would be negative 4, because the 4 to the 5th power is 1024, and so negative 4 to the 5th power would be negative 1024. So we just have the one solution for that one. All right, number 3. So for these, we're going to simplify them. Now I'm going to break this up into 3 pieces. I like doing that better just to make sure that I don't miss anything, and then I'm going to put it all together in the end. So we're going to have the cubed root of 27. We're going to have the cubed root of x squared and the cubed root of y to the 8th. Now the cubed root of 27, that simplifies nicely because 3 times 3 times 3 would be 27, so that would give us 3. The cubed root of x squared, now that can't simplify because I only have 2 x's and it's the 3rd root, so we could only remove groups of 3 of the same value, so that would just stay the cubed root of x squared. And for this last piece here, the cubed root of y to the 8th, well, 3 goes into 8 2 times with the remainder of 2. So there's going to be 2 y's left over. So now I'm going to merge this all together into 1. So outside the radical, I'd have a 3, and then I'd also have a y squared. And then under the radical, we're going to have x squared and y squared. So that would be your answer for 3A. All right, let's look at 3B. For 3B, I'm going to break this up into 3 separate parts again. So we were going to have the 4th root of 32. We're going to have the 4th root of a to the 5th, and the 4th root of b to the 40th power. All right, starting with the 4th root of 32. Now that does not simplify evenly. Now if you recognize, that's the same as 2 to the 5th power. Okay, because 2 times 2 times 2 times 2, 2 times itself 5 times would be 32. So 2 to the 5th power is 32. So that means if we're dealing with the 4th root of that, remember 4 goes into 5 one time. So we can factor out 1, 2, but we're going to be left with 1, 2 remaining under the radical. So that 4th root of 32 simplifies to be 2 times the 4th root of 2. And the 4th root of a to the 5th, well, 4 goes into 5 one time, so we'd have a, and then we'd have 1 remaining. 4 goes into 5 one time with the remainder of 1. And lastly, 4 goes into 40 10 times, so here we would just have b to the 10th power. So if we put this all together, we would have 2a times b to the 10th power, and then under the 4th root, we would still have 2a. So that would be your answer for part B. All right, let's look at number 4. So with 4 here, with both a and b, we're solving these equations. Now remember, sometimes we're going to have 2 solutions, sometimes we'll just have 1. And I'll remind you how to tell which one's which. So starting with letter A here, I'm going to divide both sides by 2. If I divide both sides by 2, I get 64 equals h to the 6th power. Now since we're dealing with an even root, when I take each side to the 6th root to undo that 6th power, that means I'm going to have 2 solutions over here, because there's 2 different numbers that I could that I could take to the 6th power to get 64. Now the 6th root of 64 turns out that that's going to be 2. So our answer would be h could be plus or minus 2. Because 2 to the 6th power, yes, that is 64, but negative 2 to the 6th power is also going to be a positive 64. So anytime we have to take and apply an even root to both sides, we're going to have 2 solutions, a positive and a negative. Now for this last one, when I take and divide both sides by 2, I get 27 equals r cubed. Now when I take the 3rd root, now this time this is an odd root. So the odd root undoes the 3rd power, or the 3rd root undoes the 3rd power. So our answer is just going to be r equals, and the cube root of 27 is just 3. So negative 3 to the 3rd power would be a negative 27. So that's why negative 3 is not a possible solution, but 3 cubed would equal a positive 27. So that is our only solution. All right, let's look at number 5. So in number 5, we have a lot of problems to do here with a through h. Some of these are going to be easier than others. Now you just want to make sure that you know all these different properties of exponents. So when we're multiplying, and the bases are the same, we're going to add the exponents. But when we're multiplying numbers, that's still just normal multiplication. 2 times 3 would just be 6. And for the x's, again, we're going to add the exponents. We'd have 1/3 plus 1/2. Well, we're going to change those exponents to have a common denominator. So that that 1/3, I'm going to change that to be 2/6, and 1/2 would be the same as 3/6. So now we have a common denominator, so we can add those together and get 5/6. And actually, you know what? It says that we need to put this in reduced radical forms. Right now I still have this as an exponent, and so I wanted to change that. So that 5/6 only applies to the x. So this would actually be 6 on the outside. Then we'd have the 6th root of x to the 5th power. That would be your answer in radical form. All right, let's look at letter B here. So in letter B, the first thing I want to do is, there's a couple ways we could do this one, but personally what I like to do is reduce first before applying any other exponents. So inside of parentheses, I see that 4 goes into both 4 and 28 evenly. And with the b and the c, those are different bases, so we can't do anything with those, at least not right now. So we're going to have b cubed over 7c to the 4th, all being raised to the 1/2 power. So we're going to have b to the 3/2 power, and we'd have 7 to the 1/2 power. C, now 1/2 of 4 would be squared, so we just have c squared. Now it says to write this in radical form. Now something's going to, hopefully you'll recognize something here in a second, that when I multiply, whoops, let me put the c first. So the c is not going to be under radical, so I'm just going to put that outside the radical. So we'd have 6c squared times the square root of 7. Now remember, we cannot have a square root in the denominator. So to get rid of that square root, I'm going to need to multiply the numerator and denominator by the square root of 7. Because what's going to happen then is I'll have b, oops, and I forgot to put this underneath the radical too, so this will be b cubed, or the square root of b cubed. So underneath, in the numerator, underneath the radical, we're going to have the square root of 7b cubed. There we go. In the denominator, the square root of 7 times square root of 7 would be square root of 49. Square root of 49 is just 7. That's our whole goal there, is to get this, get rid of the radicals. So we have 7c squared in our denominator. Now that can't be reduced, so that would be your final answer. Now you might be wondering, well, wait a minute, can't these two 7s cancel out? Well, this 7 and this 7, we cannot cancel those out. Oops. And the reason why is because that numerator, that 7 there, is underneath the radical. And when it's underneath the radical, you can't do anything with it. You can only reduce if it's outside the radical. So this would be our final answer for 5b. All right, let's look at 5c. Again, with these, I like to simplify before I do anything else. So underneath the radical, I notice that 9 goes into both 27 and 36 evenly. 9 goes into 27 3 times. Let me use red. And 9 goes into 36 4 times. And then with the x's, here you have 1x in the denominator, and we have 7 up on top. And so that's going to take out 1 from the numerator, or you can just take and subtract the exponent. 7 minus 1 would be 6. And with this one, 3 minus 1 would be 2, or you can think of it that you'd have 1y in the denominator with 3 y's in the numerator. And so now we're going to be left with 2y's in the numerator, or y squared. So let me rewrite this now, so with our reduced form. So we're going to have the square root, and then under the square root, we're going to have, and actually, you know what? Let's just do this and kill 2 birds with 1 stone. So I'm going to write this as a square root in the numerator of 4x to the 6th y squared. And the denominator, I'm going to have the square root of just 3. Oops, I don't need anything else, just 3. Okay, before I do anything with the square root of 3, because as you can probably guess, we're going to have to do something with that, I want to simplify that numerator. The square root of 4 would be 2. And remember, this is a square root, so if I want to put 2 there, I can. 6 divided by 2 would be 3, so now we would have x cubed. And 2 divided by 2 would be 1, so we'd have y to the first, or just 1, over, or just 1y rather, over the square root of 3. So just like the previous one, you cannot leave a square root in the denominator. So I'm going to multiply the top and bottom by the square root of 3. And when you do that, we get 2x cubed y times the square root of 3 in the numerator divided by 3 in the denominator. And the fact that I simplified so much at the very beginning means that here at the end, there's nothing that I can reduce. So this would be your final answer. 2, and then we would have x cubed times y times the cubed root of, or times the square root of 3, all divided by 3. All right, let's look at letter D. So with letter D, we have the cube root of 2x to the 5th times the cube root of xy squared times the cube root of 8y. Now, since we're multiplying, we could just go ahead and multiply all these values since they're all underneath the same cubed root. So we can combine those. So I'm going to write this as underneath the giant cubed root, 2 times 8. So I'm going to multiply the numbers together. 2 times 8 would be 16. And then the x's, I have an x to the 5th and an x. X to the 5th times x would be x to the 6th. And then I would have a y squared times y, and that's going to be y cubed. So I have the cube root of 16x to the 6th, y cubed. Now let's simplify that. Now the cube root of 16, well, 16, if that's 2 to the 4th power. Okay, so this is the same as 2 to the 4th power. So now 3 goes into 4 one time. So we could factor out a 2. And we're going to have 1 remaining. Now I'm going to put a gap here because we might have some variables here. And we're going to have 1 remaining. 3 goes into 4 one time with 1 remaining. So we'd have a 2 that comes out and a 2 that remains under the radical. And then with the variables, 3 goes into 6 2 times. We'll have x squared. 3 goes into 3 one time. So just have a plain old y. And again, I don't need that big of a square root, so I'm just going to shorten it. So that would be your final answer. 2x squared y times the square root of 2. Oops. Cubed root of 2. Cubed root of 2. All right, let's look at letter E. Now with letter E, in order to add or subtract roots, we need to have like terms. In other words, we need to have the same values under the root. So I'm going to change each of these. So I'm going to look at this as 2 times the square root of 4 times 3. So I'm looking at perfect squares here that I could use to multiply times another number to get 12. So 4 is a perfect square times 3 is 12. Then we'll have minus 3. 27 breaks down to be 9 times 3. Now if you notice, there's a pattern here. It's because we could take the square root of 9, but I can't take the square root of 3. Plus 3 times the square root of, and then this would be 25 times 3. I have another 3 here. So watch what happens now when I take and simplify these, because the square root of 4 would be 2, and then I already have a 2 outside of there. So I'm going to multiply the 2 that I factor out times that 2, so we're going to get 4 times the square root of 3. Minus, the next one, square root of 9 is 3. So again, I already have a number outside of there, another 3, so 3 times 3 would be 9. And then we're left with the square root of 3. For the last one, square root of 25 is 5, and 5 times 3 would be 15. And we're left with the square root of 3. So now we can combine like terms because they all have a square root of 3. And that's going to stay a square root of 3. Okay, don't do anything with the 3's. It stays a square root of 3. But the outside there, we're going to combine those terms. So 4 minus 9 would be negative 5, plus 15 would be 10. So we get 10 square root of 3 for letter E. All right, for letter F. We're going to multiply these together. I'm going to need a little bit of space here, so I'm going to do this down here. So we're going to multiply these two quantities. So it doesn't matter where you put them. I'm going to put 4 square root of s, 4 square root of s in that first term minus the square root of 3. And over here we'll have the square root of s, and then 5 square root of 3. So when I multiply these together, now square root of s times square root of s would be square root of s squared, which is s. And so square root of s times square root of s is just s. So we get 4s there. Square root of s times 3, well, that's just going to be 3s underneath the square root. Let's see if we can write that better. There we go. So it's going to be negative square root of 3s. Okay, in the next row, 5 square root of 3 times 4 square root of s. Well, 5 times 4 is 20. Then we have the square root of 3s. And then 5 times negative square root of 3, 5 square root of 3 times negative square root of 3, that's going to be negative. Square root of 3 times square root of 3 is just 3. When I multiply that times 5, though, I get 15. So that'll be negative 15 there. So this will be your answer. So we're going to combine like terms. So we have the 4s. It's going to stay a 4s. Now 20 times the square root of 3s minus 3 times, or minus the square root of 3s, those two we can combine. And this would be the same as a minus 1. So 20 minus 1 would be 19. So it would be plus 19 times the square root of 3s. Then we have minus 15. None of those are like terms, so we cannot combine any of those. That would be your final answer. All right, let's look at letter G. So with letter G, I have two terms in the denominator. So we're going to multiply by its conjugate, 1 plus the square root of r. I have to multiply the top and bottom by 1 plus the square root of r. Now, nice thing about multiplying by the conjugates is when we multiply them together, really all we're worried about is multiplying the first terms together and the last terms together. So 1 times 1 is 1, and negative times a positive is going to be a negative, and square root of r times square root of r would just be r. So our denominator is going to be 1 minus r. Now our numerator, we just distribute the 3 through, so we'd have 3 plus 3 square root of r. We can't put that 3 with the r, because the 3 is not under a radical where the r is. So we would just have it as 3 times the square root of r. And that would be your final answer for letter G. There's nothing more we can do with that one. Now letter H requires a little bit of extra work. So first off, so there's a couple different ways we could do this one. But one way would just be to start by multiplying by the conjugate. Okay, so the conjugate, remember they have the same values, just the opposite sign in between them. Okay, so just like the previous one, we're going to multiply these together. Now, this is going to be tricky. 3 times 3 is 9. Now, square root of 12 times square root of 12 is 12. And then 3 times 3 is 9. And it's also going to be a negative 3 times 3. So it's going to be a negative 9. But we're going to have negative 9 times 12, which is 108. So we have 9 minus 108, which is negative 99. So our denominator is negative 99. Now for our numerator, where we're going to have to use another one of these boxes, because these are not conjugates, so we can't just do that trick that we did in the denominator. So we're going to have 2 plus the square root of 12 times 3 plus 3 square root of 12. So 3 times 2 is 6. This will be 3 square root of 12. 3 square root of 12 times 2 will be 6 square root of 12. And lastly, square root of 12 times square root of 12 is 12. Times 3 is 36. So if I combine like terms, 36 and 6, those are like terms. Those add together to be 42. And then 6 square root of 12 plus 3 square root of 12 is 9 square root of 12. Now the one thing I notice is that every single one of these are divisible by 3. So 3 goes into 99 33 times, 3 goes into 9 3 times, and 3 goes into 42 14 times. And I also notice that we have this negative. So you can either put this negative out in front, but if you put it out in front, you want to make sure you put it at the same level as the square root. You do not want to just put it up here with the 14. So what I like to do is instead of putting it in front, I like to distribute it times everything in the numerator. So I'm going to erase that. I'm going to make this negative and make this negative. So my answer would be negative 14 minus 3 square root of 12 divided by 33. And you know what? Even this is not our answer because I always need to look at my roots and see if those can be simplified. Now, square root of 12 is the same as the square root of 4 times 3. And the square root of 4 is a perfect square. So the square root of 4 would be 2. So this is going to simplify to be 2 times the square root of 3. Okay, but we have this 3 outside of, or negative 3 that we have outside of there. So your final answer would be negative 14. Negative 3 times 2 would be negative 6. Square root of 3 all over 33. And again, that cannot be reduced any further, because even though 3 goes into 6 and 33, 3 does not go into 14. So this would be your final answer for letter H. The only alternative for this would be if you had kept these as positive. Technically, you could have the negative here, or you could have the negative down here. But remember, it's proper not to leave a negative in the denominator. So I like to just distribute it through the numerator. All right, so that brings us to the end of the pink section. So that was a longer section, so hopefully that answered any questions that you had. And if not, make sure that you get those questions answered directly from me or whoever your math teacher is.